Okay. So if you're asked to simplify or evaluate, and let's say I gave you the following. Right, there's a couple different ways that you can approach these types of problems. You can approach them by either putting them into rational power form or by putting them into radical form. It doesn't matter either way. I'll show you how you can solve it in each direction. And so one way is to put this into radical form. So if we were to convert this into a radical, we'd have our radical symbol, a base of 36, a power of 3, and an index of 2. And now remember, one of the properties of radicals is it doesn't matter whether you apply the radical first or the power first. So this is equivalent to taking the square root of 36 and then cubing that. Well, what is the square root of 36? 6, and 6 cubed is 216. And now you guys are expected to know perfect cubes up to 6 cubed. And so you need to know 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Okay, 5 cubed is 125, and 6 cubed is 216. Okay, that's as high as I'll go as far as the problems that you can't use a calculator to work on, but you do need to know those powers. Right, now, the alternative to this is to solve it by using the rational power form. It's already in that. If that's the case, what you want to do is you want to be able to recognize that 36 can be expressed using or as an exponent using a smaller base. So we can express 36 as 6 squared. So if you think of that as 6 squared to the power of 2/3, instead of using radicals and their properties, you can just use the properties of powers. What do you do when you take a power to a power? What do you do with the powers? You multiply. So you're looking at 6 to the 2 times 3/2. The 2 and the 2 here cancel, leaving 6 cubed, which is 260. So you could use either of those methods. It doesn't matter. All right, try this one on your own, please. Let's see if you can simplify this problem. All right, if you approach this problem as the radical, so I'll do it like I did up here, what you can do is, regardless, what does the negative power do to this whole fraction, this base? It flips it, right? So this becomes 27 over 125 to the 2/3. And so that's probably what I would apply first, is the negative power. And then if you were to write this as a radical, it would be the cube root of 27 squared over 125 squared. Okay? Or again, you can think of it as this whole quantity squared. Okay? And it doesn't matter which one you choose to use first. So I'm going to use the cube root first. So the cube root of 27 is 3. Cube root of 125 is 5. That whole thing is squared. And now the properties of square, or the powers, it applies to both parts of a quotient. So 3 squared is 9, 5 squared is 25, and you get your solution. And now you could also apply the rules of rational powers right away. And you can express 125 as being 5 cubed, 27 as being 3 cubed, and recognize that form immediately. And if you do that, what you can see again, if you apply the negative power first, it flips. It becomes 3 cubed over 5 cubed, all to the positive 2/3. And then a power to a power, this power applies to each part. So 3 cubed times 2/3, 5 cubed times 2/3. The 3's cancel in each of these cases, so you get 3 squared, or 9, over 5 squared, 25. And once again, either way, it leads you to the correct answer. It doesn't matter which form you choose. Right. So try these last two sample problems on the sample 13. And then we'll go through some problems that'll be similar to what you'll see on your quiz. All right, so if you're able to do this in your head, which at some point hopefully you are able to, you can kind of think back and forth. So any rational power denominator is the index. So we're looking at a 2, so square root. What is the square root of 4? 2, and then 2 to the 5th is... Now again, this is one of those numbers, you don't need to know this offhand, but you should be able to find it pretty quickly, right? If you double your value each time, so we start with 2, double it, we get 4, 8, 16, 32, so 2 to the 5th is 32. Okay, and then with b, the negative power is going to move our base into the denominator, so we're looking at a denominator here, but we can take the cube root of 27, which is 3, 3 squared is 9, and so you can get a 1/9 for your answer. And now, you don't have to necessarily be able to do that mentally. If you're writing it out, you can think of this as 2 squared to the 5/2 power. The 2 and the 2 cancel, leaving 2 to the 5th, which is 32. You could also think of it in terms of radical form, base of 4, power of 5, index of 2. Take the square root of 4 first, which is 2 to the 5th, which is then 32. Okay, so you can use either of those methods. Okay, for this second example, you could do, again, same idea. You could take it in rational exponent form. 27 is 3 cubed to the negative 2/3. Okay, the 3's cancel, leaving you 3 to the negative 2. The negative is going to move our base to the denominator, and then 3 squared is a 9. Okay, or you could also do it the other way, where you write it as a radical. The negative is going to move our base to the denominator, 27. It's an index of 3, a power of 2. And then just think of it in that form. The cube root of 27, quantity squared. Cube root of 27 is 3 squared, which is 1/9. Again, you have some choices to make, whatever's most comfortable or familiar to you.